Radio direction finders are set up at 2 points A and B, which are 2.5 miles apart on an east-west line. From A, it is found that the bearing of a signal from a radio transmitter is north 36 degrees 20 minutes east, and from B, the bearing of the same signal is north 53 degrees 40 minutes west. Find the distance of the transmitter from B. Okay, so we've got these bearing directions here, and so we learned that how to interpret these is that so transmitter A, they're 2.5 miles apart on an east-west line, so they've got that labeled here, and then from A, it is found that the bearing of a signal from a radio transmitter is north 36 degrees 20 minutes east. So what does that mean? That means that a bearing specified like that direction is, so that you first specify the north or south direction, so this is the north direction, then you give an acute angle, and then either east or west. So you're going to be to the east or the west of the north line here. So this is 36 degrees 20 minutes east. So that's the bearing of the transmitter from A. And then from B, it detects the signal at 53 degrees 40 north, 53 degrees 40 minutes west. Okay, so we can see that we can get these angles because this angle and this angle are complementary, and this angle and this angle are complementary. So, and actually, you can see that since if these two angles are complementary and these two angles are complementary, then these two angles are going to be complementary. And if you have two angles in a right triangle that are complementary, then it's going to be a right triangle. And so, yeah, this is actually interesting in that for a situation like this, and I guess it might be this, and it like work out this way for a lot of navigation, but you're always going to end up with a right triangle this way. No matter what, if your measurements are from, north and this one's east, this one's west, you're always going to have a right triangle. So here's an application that actually does involve, like a pure trigonometry. So interesting. All right, 36 degrees, 20 minutes. What is that as a decimal? So how many degrees is 20 minutes? There's 60 minutes in a degree. So that's a third of a degree. So 36 and 1/3 degrees is what? That's 109 over 3. So 109 over 3, and let's subtract. So we got 109 over 3, and then, so that is what? 36. So what's 90 minus 109 divided by 3? 161 divided by 3. It's like 50-something degrees. So, okay. Okay, now 53 degrees, 40 minutes. 40 minutes is how much of a degree? So 53 and 2/3 is 161 divided by 3. So this is, and then if we take 90 minus that, so 90 minus, it's 109 divided by 3. So 109 divided by 3 plus 161 divided by 3 should be 90, which means that 161 plus 109 would be 270. Yeah. So this is a right triangle. And across from the right angle is the hypotenuse. So 2.5 is the hypotenuse. Okay, so what are they asking? They want the distance of the transmitter from B. So they want this distance. We'll call this X. This distance. So we can use, the sine of this or the cosine of this. So let's just say the sine of 161 divided by 3 degrees is opposite over the hypotenuse. So, okay, we want to make sure we're in degree mode, switch to degree mode. Then sine of 161 divided by 3 times 2.5 is 2.01 miles. There we go.